Hi, I'm Eric Dodds, Head of Customer Success here at RudderStack. Today I'm going to walk you through our Data Governance API. Here's a quick overview of what we're going to cover. First, we'll talk about a few common problems that data engineers and developers face related to maintaining clean customer data, and how we've worked with our customers to build API-first solutions to those problems. Then, after a high-level explanation of what the Data Governance API is, we'll jump into a demo of the API with a real-world example. Lastly, we'll take a quick look at an open-source Google Sheet plugin that one of our users developed so they could better collaborate with product managers on schema management. Okay, let's talk about common problems data engineers face in trying to maintain clean data. Maintaining clean data as part of managing customer data pipelines is challenging, especially for companies at scale that manage multiple sources of data across multiple platforms. Inevitably, instrumentation is modified, changed, or doesn't go through QA, and the data that comes through on the other side has problems. It could be missing fields, capitalization errors, or inconsistency in data types. Even when small, these can cause big problems for the customer experience and analytics. This is because the tools that drive analytics and the customer experience rely on accurate data to do their job. We'll look at this in a bit more detail later. Either way, validating events is a non-trivial challenge. Companies often address this in two ways. Many leverage both. First, many companies have some sort of shared spec for events. This is often some sort of tracking plan and, as simple as it sounds, often lives in a shared spreadsheet like Google Sheets. While there are tools like Iteratively and Avo that help solve this problem, they often require alignment across teams, which is a significant effort in and of itself. Either way, this approach attempts to influence the quality of data before it enters the system. Alternatively, many companies assess events that have already come through the system. They'll use a data warehouse or a data lake to store the events and then manually verify random samples. Oftentimes, they'll use scripts to make the process easier. No matter the approach, the conclusion is the same. Customer data governance is hard and often involves multiple processes and tools. At RudderStack, we've worked with our customers to build API-first solutions to these problems. RudderStack is a customer data pipeline company, so our customers deal with data hygiene issues every day. As we explored how to help them maintain clean data, one requirement became clear. They wanted an API, not a UI. This makes complete sense. At scale, data governance UIs can become incredibly tedious to maintain. Additionally, our customers wanted to enact data governance activities in the context of their own internal processes, not add an entirely new process to an already complicated effort. We worked with those same customers to build the Data Governance API. Let me give you a quick overview of the Data Governance API. Then we'll jump into a demo. The Data Governance API gives data engineers and developers access to diagnostic information on their event stream via endpoints. This API-first approach allows teams to integrate those diagnostics into their existing workflows, including CI/CD workflows. A few practical examples of how companies use the API include listening for changes in event schemas, creating internal alerts when new events come through the system, and gaining a better understanding of the frequency of event properties. All right, let's explore the features of the Data Governance API. First, note that most of our customers integrate the API into their existing workflow, but in this demo, we're going to use Postman to visualize the workflow for the walkthrough. Here are the features we'll cover. We'll access event models, we'll access event schemas, we'll access event metadata, we'll count keys for an event model, and we'll access missing keys for an event model. One last note before we dive in. Currently, this API only supports pulling diagnostic information about your event stream. We're actively working on features that will allow you to act on your data programmatically to do things like event blocking, schema validation, and restreaming. All right, let's jump in and look at the Data Governance API with a real-world example. Let's say a product manager notifies you that there seems to be a problem with product purchase events from your e-commerce site that's creating issues in a downstream tool called Braze. We can use the Data Governance API to investigate this issue. First, let's use the event model endpoint to pull event models from the e-commerce site and see if there are multiple product purchase events. This endpoint will return all event models that have come through our data plane. Also, note that the term event model indicates a distinct event. The easy way to think about this is that each event model has a distinct event name. We'll grab our write key from the e-commerce SDK, place it in a call, and grab the return data. If we look at the events, we can see that there are indeed multiple models for the product purchased event. Notably, one version of the event is called product_purchased, and the other is called product space purchased with capital letters at the beginning of each word. Notice that the API also returns the total count of the events. We see that there are fewer occurrences of the product_purchase event, which might indicate that particular model is causing the problem in Braze. If that event is also being routed to the warehouse, though, the analytics team is going to have issues with reporting as well. Let's hop over to Snowflake. As we can see, even though the table name looks correct because of the way that RudderStack handles schemas, the primary identifier for the event has different values, which is probably causing issues in downstream destinations and for the analytics team. After confirming that someone has made a mistake instrumenting that event and notifying the dev team that a fix is needed, we can quickly clean up the live data stream using a simple transformation on the Braze destination in RudderStack. This JavaScript function will rename any product_purchase events that come through to product space purchase with capital letters so that no downstream tools are impacted. Depending on the needs of the analytics team, we could also use RudderStack's warehouse as a source feature to pull the product_purchase events back through the system, correcting the name either in the warehouse using SQL or via this transformation. Either way, the events would pass through RudderStack again, including timestamps, and populate the correct table in the warehouse, meaning no one has to do query cleanup for reporting. Okay, great, we sorted that problem out, but in communicating with the analytics team, someone tells us that some of the product purchase events have information on whether an item is a sale item and other events don't. But there have been requests for reports that show the sale status for every product. Again, let's use the Data Governance API to investigate. Let's grab the event ID for the primary product purchase event and pass it to the event versions endpoint, which will return every distinct version of the schema associated with this event model. We can see that there are two schema versions for this particular event. If we diff the payloads, it'd become clear that the latest version of the event includes a new property called sale_item. Let's dig a little deeper. If we pass the same event ID to the event model metadata endpoint, we receive a sample of the event versions for this model, a total count of this event model, and the frequency of values. Note that the metadata references a master schema for that event ID, which includes keys from every version of the event. Here we can see again that the second version of the event in the samples includes the sale_item property. Now, if we're curious about the actual count of keys, we can pass the same event ID to the key count endpoint, which will return a total count of each key associated with this event. Note again that the return values reference the master schema for the event, which includes keys from all event versions. As expected, the number of events with the sale_item property is far lower. This is a simple example, but note that for more complex situations where many event versions are present, the Data Governance API allows you to perform even deeper analysis, offering diagnostic data on event versions. If we wanted to do that, we'd grab the version ID from the first version of the primary product purchase event model. As opposed to the master schema, this version ID represents that distinct version of the event. If we pass that version ID to the version metadata endpoint, we'd receive all of the metadata for that distinct version. Now we can also use this version ID to compare this distinct event version to the master schema and determine if there are keys present in the master schema that are not present in this particular version. To check for missing keys, we can pass the version ID to the version missing keys endpoint, which will return keys from the master schema that are missing from this particular event version. As expected, the sale item key is returned. Future versions of the event included that key, meaning it is present on the master schema, but this particular early version of the event doesn't include it. Now, going back to the issue the analytics team is facing with missing data, we can update our transformation to check for the sale_item property and set it to false if it doesn't exist, ensuring that all future events will include this data point. Also, if there's a needed backfill, We could again build a table in our warehouse that flags all past purchase events with a sale item key and run them back through RudderStack using warehouse as a source, meaning the analytics team would be able to report on this new data point historically. Now that we've demoed the features of the Data Governance API, let's quickly look at an open source Google Sheet plugin that one of our users created to better collaborate with product managers on schema management. In a few simple steps, you can connect the Data Governance API to a Google Sheet. If you want a copy of the Sheet template, check out our docs or send me an email at eric@rudderstack.com. This Google Sheet allows you to pull event models and event versions from the Data Governance API. Do note that if you're going to pull event versions, you should use a separate Google Sheet for every source. First, let's get event models. I've added my details to the template, and I'll head over to the Event Models tab. When I run the script for this data plane, we can see both product purchase events that we looked at earlier. Next, let's get schema versions for our events. When I run the script and it finishes, the output is placed in a new sheet in the folder that we specified in the settings. Here you can see the same schemas that we looked at before in the results and Postman, but now they're in the Google Sheet as well. Distinct events are stored in individual tabs in the sheet. Here you can see that there are two versions of the primary product purchase event, and of course, there's a sale item property in the second schema version. And that's the end of our walkthrough of the Data Governance API.